I am Judith Manu Gracelyn. I am going to discuss a topic about coefficient of correlation by rank differences. In statistics, a rank correlation is any of several statistics that measure an ordinal association, the relationship between rankings of different ordinal variables or different rankings of the same variable, where a ranking is the assignment of the ordering labels first, second, third, etc. to different observations of a particular variable. A rank correlation coefficient measures the degree of similarity between two rankings and can be used to assess the significance of the relation between them. For example, two common non-parametric methods of significance that use rank correlation are the Mann-Whitney U-test and the Wilcoxon-Sain rank test. Correlation coefficients are explained by Spearman's, Kendall's, Goodman's and Crookson's and Somers. An increasing rank correlation coefficient implies increasing agreement between rankings. The coefficient is inside the interval -1, 1 and assumes the value 1 if the agreement between the two rankings is perfect. The two rankings are the same. 0 if the rankings are completely independent. -1 if the agreement between the two rankings is perfect. One ranking is the reverse of the other. Spearman's rank correlation coefficient. In statistics, Spearman's rank correlation coefficients are Spearman's rho, named after Charles Spearman. It is a non-parametric measure of rank correlation. It assesses how well the relationship between two variables can be described using a monotonic function. The Spearman correlation between two variables is equal to the Pearson correlation between the rank values of two variables. While Pearson's correlation accesses linear relationships, Spearman's correlation accesses monotonic relationship. If there are no repeated data values, the perfect Spearman correlation of +1 or -1 occurs when each of the variables is a perfect monotone functions of the other. Next we see about the Kendall rank correlation coefficient. In statistics, the Kendall rank correlation coefficient, commonly referred to as Kendall's tau coefficient after the Greek letter tau, is a statistic used to measure the ordinal association between two measured quantities. A tau test is a non-parametric hypothesis test for statistical dependence based on the tau coefficient. The Kendall correlation between two variables will be high when observations have a similar correlation of 1. Relative position label of the observations within the variable first, second, third, etc. between the two variables, and low when observations have a dissimilar or fully different for a correlation of -1 rank between the two variables. In statistics, Goodman and Crookson's gamma is a measure of rank correlation. Example, the similarity of the orderings of the data when ranked by each of the quantities. It measured the strength of association of the cross-tabulated data when both variables are measured at the ordinal level. It makes no adjustment for either table size or ties. Values range from -1, 100% negative association or perfect interventions, to +1, 100% positive observations or perfect agreement. A value of 0 indicates the absence of association. Next we see about the Somers D. In statistics, Somers D, sometimes incorrectly referred to as Somers D, is a measure of ordinal association between two possibly dependent random variables x and y. Somers D takes values between when all pairs of the variables disagree and when all the pairs of the variables agree. Somers D is named after Robert H. Somers, who proposed it in 1962. Somers D plays a central role in rank statistics and is the parameter behind many non-parametric methods. It is also used as a quality measure of binary choice or ordinal regression and credit scoring models. Conclusion. Correlation coefficient describes the strength and direction of an association between variables. A Pearson correlation is a measure of a linear association between two normally distributed random variables. A Spearman rank correlation describes the monotonic relationship between two variables. Thank you.